Okay, so we had left off with talking about the different organic families, I believe. So, who can we pick on? Okay, so Caitlin, then you get to pick an organic family and just name any organic family. Okay, then who's next? You. Okay, who's next? What is it? An organic family. Okay, now who's next? Okay. Now, it's hard to visualize when people are naming some of these as we go. So we've heard ketone, and you said what? Alkene? Alkane, okay. No, yeah, okay. So then, what's significant about an alkene then? That's right. Who's next then? Okay. Shrugging your shoulders is not an answer.
I didn't shrug my shoulders. I just like this.
Oh, yeah. See, we probably may have an audience tune in later, so they can't see what's going on. But that's why I got to give this radio play-by-play. That, and I thought I saw you shrug your shoulders, so I said that's not an answer. But making your eyes bigger isn't an answer either. But
Wait, we said ketone and we said
we heard alkane, we heard ketone, we heard alkene.
so alkyne.
Okay,
The triple
that's right. Then who's next?
Alex.
Okay,
Esther.
okay, and then finally. Okay, aldehyde. So now what we get to do, okay, we get to pick on you, just you three. Because you all said something that had this in common. You said ketone, which is fine. You said ester. And then you had said aldehyde, which is fine, correct? So what might those three have something in common? And that's exactly what it is, but what is that called, though? It starts with a C. It was just a very brief response that we said it's a blank carbon when you have those that have a double bond oxygen, just like you three had stated. And we could find it, and it's just one of those things to where, unless you have a deep background in this, it's probably just not going to stick out in your mind, okay? And what I mean by that is this on computer? Yep. See if we can find it. It's close. It sounded. Could say that again. Carbonyl oxygen. I'm looking to see where it says that, and I'm not finding it either. But it's a carbonyl carbon, which means those all have something in common. They've got a double bonded oxygen somewhere on the compound. So I think it's this here. Okay, all these compounds contain a double bond oxygen somewhere on the carbon. And of course, the one that's left over is your acid. And we call those, again, a carbonyl carbon. So we begin with talking about the alkanes. Okay, so one of the things that come to alkenes is that it's something that comes out of crude oil. So we harvest it out of the ground. You could say we drill for it and then have to refine it. So when you look at the significance of, you could say, the alkanes or crude oil or whichever, which one of them do you think could be the most important to you? When you look at this, okay, not this, but when we're talking about this, which one might be the most important in your opinion? You know, it's not what I was going to say, but when I think about it, you're not wrong either, and I'll explain why. What might be something up there that people have to have on a daily basis? Yeah, different types of drugs, whether it's something for maybe it's a blood thinner that people need to take on a daily basis, or maybe it's some heart medication or something to that effect. But when you say plastics, to me, that's probably not wrong either, because we just can't live without plastic. We package food in it, all the different types of materials that some of you will be working on in a hospital, because when you become a registered nurse, any type of medical equipment, unless you're in the operating room where it goes through a sterilization process, you don't do that with a lot of different type, whether it's needles, syringes, or anything like that. Everything's wrapped in plastic. So when you say plastic, to me, that's probably not wrong either. But a lot of the prescribed drugs that we need comes from that of alkanes. Okay. We don't have a whole lot to go over today. We've got to do those two compounds on the board, and then we'll get you on your way. So when we're looking at this, okay, when your carbons are bonded like this, it's when you can rotate that around. I don't think the background's too bright, just for a moment. It's when you can rotate these around. We're talking about a free rotation in that manner. Okay. And one of the aspects with this, probably one of your least favorite problems to address is that of isomers. Oh, I hate isomers. I don't know if that's what went in the back of your mind. But at this level, we talk about conformational isomers as well. And we'll address that at a later time. Okay. So I want to do this one. And then I think we're probably about done. Yeah, there's your constitutional isomers. We'll get to that probably tomorrow. Okay, I just want to talk about this, and then we're going to open up your books. And this is old knowledge, or old news. We've already talked about this, but this is what you would be referring to. We really don't use a condensed structural formula except when we get to the lipids. Okay? And I'll give you an example of that here shortly. So when it gets to later on this afternoon, family talk about, I hope it rains. Have you heard that? Is that what Pops is saying?
No.
We think we have enough to push it over the finish line?
Yeah.
Okay. Yeah, I know, right? Just needs to be a little cooler. Um, but isn't this, all this heat is maybe needed just for tasseling corn, maybe not for filling out the ear. I really don't know. But yes, being a little cooler would be better. It's probably hard on the cattle. It goes without saying that that would be common sense. Okay. So cross-country practices are now after school. You wished it would have been that years ago, but that would have, it wouldn't totally conflict with volleyball, but then you wouldn't have to get up so early either. Okay. So, like we said, that's it for here. Okay. And maybe some of you have named these already. We just didn't get to these two compounds. So, since this is a derivative, is this a condensed molecular formula or an expanded one? Yeah, this is a condensed structural formula. So, one of the things that we deal with is, we already know, name your longest parent chain. Okay? Then is anything off of that? Okay? So our longest parent chain is how many carbons? Okay? And then what's branching off of that? A methyl? See, this is where you get to impress people. Or if you know someone who's like this. One of the things we talk about, there's nothing wrong with labeling these where they're at. Okay, there's your methyl group, there's your ethyl group, and then you want to, what do you want to talk about? Me. That's a way to impress people. You can talk about me. Yeah. I don't know. Just sounds good. Oh, you talking about Toby Keith?
Yeah.
Talk about me, or something like that? Yeah. All right. So you correctly said, okay, we've got this, okay, and then where are our derivatives located at? Okay, but they have to be written specifically. Okay, so then on which carbon? Then what? Okay. So there's a lot of information that you already know when you're looking at this because, okay, as we said before, what's that telling you? Exactly. They're all single bonded, but it's also an organic family. You're right in both cases, okay? So this is your alkane family. This is telling you something important. Yeah, you have an 8-carbon base chain here. This is saying you have a methyl group, or CH3, located on your second carbon, C2H5 located on your fourth one. Okay, so dashes separate numbers from letters, and then commas separate numbers from each other. We don't have anything like that. The only reason that would be different is if we had this, okay, then we have to change this to 2, comma, close, 2, comma 2 dimethyl. Yep, that's correct. So one of the things I think about from time to time over the years with not just this class, but you put in for physical science and a little bit of general chemistry, would you feel confident walking into an organic class in college, or you think still having this one is going to be a great advantage? You're going to find out why here in just a moment when we open up these books, but to me, oh my gosh, when we talk about Reese, thinking she's had a good background because she took this class. She's taken organic chemistry, and I think I said Dr. Madsen. I don't think that's right. I think it's Dr. Halawish. I think he's Egyptian. Okay, so, but regardless, having this, and you already have a light background in this just because of having it twice, physical science and general chemistry. But again, we go just a little bit further here in just a moment. Okay, so then what do we have here? Okay, it's an isopropyl and a methyl, and our parent chain. Okay, I'm just presuming you had that already. Okay, then notice we have this here, and then we have this here. Okay, now one of the things you're going to find out is this is just a coincidence. Alphabetically speaking, which one comes first? Right, okay? Because this is a prefix for isopropyl. You use this in alphabetizing, okay? You don't use the D in dimethyl or T in trimethyl, okay? You disregard prefixes except that one, okay? So on our third carbon, we've got what? Okay, then dash. Okay, 4-methyl heptane. Okay, so again, one of the last things you wrote down was your condensed structural formula and expanded type. See, if you were to do this, Gesundheit, okay, notice we've got 8, 10, 11. You would say C11. We already know that's got to be H24, just from the formula for that is 2N plus 2, okay? If we look at this, we're going to say this is, oh shoot, we used to count in Spanish when I was in 6th grade. What's 10? DX? DNs, then what's 11? So I don't know if that's what you would do for this. Isn't Bente something? Is that 20? Okay, say that again. Oh, it's not Bente with a Bravo B? It's victory that is in V. Huh. I don't know if I'm disappointed or I'm impressed that I can remember that, but I'm disappointed. I thought it was B as in Bravo, Bente. Oh, it's Vente. Huh. I learn something all the time, I guess. I epically failed, I guess. All right. So, again, when you look at these, you can always reverse engineer these. We know everything's single bonded, 7-carbon compound, a methyl group located on the 4th carbon, an isopropyl group located on the 3rd. Okay. So go ahead and grab or your book. I try to at least say before the pledge is maybe say, you might want to grab a book before you get settled down. And notice we're not going to chapter 3. We had talked about that already. Okay. So just some quick, if you want to call it, review with this. Okay, page 295. You may be wondering, why are we talking about organic families? Because we don't do or discuss esters, alcohols, acids in this chapter. But what the author does is chooses to put that on table 11.2. And there you can see all of your different types of organic families and then their assorted structures. Okay. So then when you look at page 297, Okay, there they give you your expanded structural formula and then your condensed molecular formula. Okay, and then I think we want to talk about the rules for naming, and I think that's, where's that located at? Okay. Okay, page 309. Okay. And then we're going to discuss a little bit what you see on page 308, and like I said, that'll be it for this. Okay, so at the bottom of page 308, it's talking about the IUPAC. I think that's International, I don't want to say Union, or International Unified Physics and Applied Chemistry. I think that's what that is, okay, nomenclature. There are only a few rules for naming alkanes by the IUPAC nomenclature system. The utility for the IUPAC rules is that they are followed correctly. They always result in the same name for the same compound. Here are those rules in order in which they must be used, okay? So one of the things you've noticed, I think it's important just to illustrate what it is that we're doing. Because once you start explaining the rules, it's kind of like, oh my God, that's confusing. I suppose you could say, I just happened to catch a little bit of a preseason game yesterday, Denver and, was it Raiders? Well, it doesn't matter. Did they change the kickoff?
Yes.
Okay. Are they faced, the kicker's like 20 yards behind everybody else? So that's what I mean. I think there's probably rules in the NFL rule book. This is the kickoff rules, and if you read that, you think, oh my God, this makes absolutely no sense.
That's what they use in the XFL. Yeah.
Oh.
They're adopting the XFL's kickoff rules.
Okay. And so I did not know that. Now we know. But like I said, once you see it, then apply the rules. I think it makes more sense. That's how we like to approach this. You see what it is we're doing, then we talk about the rules, because then we can reinforce that. So number one, the name of the law is continuous chain. We've been doing that for quite a while now, or base, or parent name. That's rule number one. Okay. Then rule number two, the base name accounts for only the carbons in the longest continuous chain. So of course what we're looking at there, it's straight. It doesn't account for these derivatives that are branching off of there. That's what rule number two is. I usually like to say, they say substituents or groups. I think alkyl derivatives makes the most sense, or halogen derivatives or something to that extent, okay? Then once you start putting double bonded oxygens on there, like we talked about then you're naming organic families, and that will come later on this semester. The names of any alkyl groups, which is methyl, ethyl, propyl, and so on, okay, is placed in front of the base name, okay? So that's just what we're doing here. Here's your base name. We put all those in front, okay? We've been doing that. Use the prefixes. We said dimethyl. If it was 2, 2, dimethyl, you would do that. If there's 3, it's trimethyl. 4, it's tetra. Now, we might see tetra, methyl, maybe, but we're not going to get so crazy getting into a penta and hexamethyl, okay? I mean, that's just kind of crazy, okay? It says alphabetize the names of alkyl groups, okay, when there are 2 or more different types of groups. Ignore all prefixes, both the branching prefix S for secondary and T for tertiary, and multiplying the prefixes such as di, tri, and tetra. Okay. Oh, and the multiplying. Why did they say that? Okay. In alphabetizing, with one exception, ISO or iso, whether it's isopropyl or isobutyl, is going to be an exception. Is not is not ignored alphabetizing, okay? Okay, number the carbons in the longest continuous chain, starting from where the end will result from the lowest number. We had said, if you play golf, what's your goal? If it's a par 4, you want to get a birdie or a 3 on there, okay? And maybe if you're really good, maybe you can, like Happy Gilmore, hit it on the green and eagle a par 4. Yeah. So, Happy Gilmore was a hockey player that started to play golf. Yeah. That's okay. And then number 4, in front of the name of each alkyl group, place a number on the carbon to which the group is attached. Use hyphens to separate numbers from words and commas to separate the numbers. Okay. So again, I think it just makes more sense to do this first, then read about this, okay? Because sometimes what can happen, you might look at this and say, oh, well, if we had another propyl group on here, you still have to go by the I, not the P, okay? All right. So on page 308, those are your alkyl derivatives, okay? So notice in physical science, the top 2, methyl and ethyl. You learned those. Then last year, we moved on to propyl and isopropyl. Now we move on to the next and final 4. Your butyl group, your secondary butyl group, your isobutyl group, and then finally your tertiary butyl, okay? So, in alphabetizing, okay, which one do you disregard the first letter for? Yes, the secondary or S and T for the tertiary one. You disregard those, okay? Also, what's not on there, you also disregard what? Yeah, your di, tri, and tetra, your prefixes, okay? So secondary butyl, tertiary butyl, those are prefixes. Dimethyl, okay, triethyl or diethyl, those are prefixes as well. Okay, so I think that's enough for today. I got your paper, and you have the rest of the time. Your next one we'll have assigned tomorrow, and then we will keep rolling from there. We'll catch up to you next time.